It has a burner on the front. Hunter Unit 3 boiler has 40 burners. And they're much bit larger than what we have here, but it replicates Hunter Unit 3. And so your fuel comes in at the front and it burns, and the flame comes down through this process. They check temperatures all the way through, plus they check to see what CO2, NOx, all your pollutants that are produced. They'll control that and monitor all that. Clear down through to your economizer sections, and then it goes on outside into a bag house. They collect the ash and they test it. It all depends on what you're burning through this process. For a year or so, this furnace was in use for a company out of England called Drax Company. They're Drax Electrical Company. They have a huge electrical force over there. They have lots of big coal-fired boilers. And England did away with coal. They couldn't use coal anymore. So that put all these great big furnaces and all this electrical grid in a lot of problem. What kind of fuel they're going to get and how they're going to use it. So they've had us test torrefied wood, sugar cane, peat moss. We've tested those products. We've ground them in our coal mill, which sits in the back here. We put in our silos, and then we use like feeders, just like the power plants do, and they monitor how much fuel goes in at any given time of what mix. And then they test it as it burns and it's processed. And then you collect all the data in the control room, and then Dr. Fry and his students would take all that data back to BYU, that analyze it all, and then they would ship it to this company and say, all right, this is your BTU quantity at this mix, at this feed rate, all the way through up until this is how much ash will build on your tubes. This ash is either very corrosive, it'll corrode your tubes, or it sticks real bad, it'll plug a boiler. I mean, they analyze all that, because that's what these big companies want to know, because they don't want to just plug a boiler or ruin one just by stuffing coal or wood in them. So we did that for several years. Right now it's tore apart, or not for several years, all last year. We're getting ready for supercritical CO2 testing. And the process for that is at the power plants, as you know, as you see a lot of steam as you drive by them, they use a Rankine cycle. That's what it's called. It's a water cycle that you turn to steam, the steam turns to turbines, and then they take it back to water, pump it back to the boiler, it starts all over again. But they're wanting to prove that you can do the same thing with CO2. And they think they can get more work out of CO2 than they can steam. That's a theory that they've worked on for years, and they've never tested it. So the Department of Energy has a contract with us and BYU, Dr. Fry, to test the supercritical CO2 cycle. And it's a 3-year process we'll be doing. And they'll be bringing in more equipment. You went by some big pedestals, poured cement pads out here. They'll bring equipment in to set on those. And instead of turning a turbine, they'll be running a safety relief valve. It'll be a valve that'll open up to replicate the work that a turbine would see, so they can tell how much energy that they're getting out of the CO2 in the process. But we'll take it up to 1,000 degrees, 3,000 pounds pressure, just like the boiler would, and we'll test all that, but on a very small scale. And then we can tell them exactly what it's going to do, whether it's going to work, whether it's not, or if it's what they think it's going to do, or if it'll be really close to that. They can prove all that. At least we hope we can. And so that's this one's purpose and why it's tore apart right now. But the L1500 was, University of Utah had it. That's why it's still this color. They had it there in Salt Lake, and they didn't want to be burning coal in downtown Salt Lake anymore because it was right down by the freeway. So they was just going to throw it away. They were scrapping it. So Senator Hinkins got with them, and Emory County says, we'll take it. And we got it from the University of Utah. It came down on many semi-loads that Utah State University sent trucks up, and also our county road took trucks up. Brought it all down. Commissioner Sittard brought his crane over. He ran the crane. Commissioner Wilson and I we're the riggers. We rigged everything, unloaded all these semis, and then Dr. Fry came down with a picture and said, this is what it's supposed to look like. And so between him and Scott Montgomery, they put it all back together. And they put all this, and it works. And it works really well. But this L1500, there's two in the world. We have one in Emery County. South Africa has one. And Germany has one that's similar to this, but not this size. But they're the only ones in the world. So that's why we've been doing testing for Drax out of England and so forth, because they hear about them, because they all know Dr. Fry, he's very well known. And they're calling in and saying, I need to test this, I need to test that, or whatever. They're wanting to test all this. Yes?
So Commissioner, are the Englishmen still here doing testing?
Yes.
Okay.
They will be. And well, they tested, we did 3 different tests for them. And I was gonna say, if I could see anything on the floor, I could show you, but we've got bags of crushed, like dust, face powder quality, kind of like the coal is at the power plants, of torrefied wood, sugar cane, and bags of that stuff. And we would put in our hoppers out here, and then we would mix it. We would bring those fuels in at different rates, different mixture ratios, and they could tell them which is the best, so you don't plug. This is a bad combination. We could tell them all that. And this process now for the CO2 would be that we could help the power plants remove CO2 from the flue gas, is the big thing, so you don't have the pollution in the air. And then they can use that CO2 back in their water cycle, in the boilers, to turn turbines. And that's what we hope that we can prove. And hopefully that will also, hopefully that'll give us a little bit more life on power plants, I hope. They still have an end of life in 45. I don't know if they'll change that, but we can always hope that it might.